Hello students, now let us start with the second lecture from some basic concept of chemistry, that is Gay-Lussac's law of gaseous volume. So you just have to concentrate on this gaseous volume. We are talking in terms of gaseous volume, remember. Okay, so here is the statement for this law. When gases combine or produced in a chemical reaction, they do so means they react or produce in a such a way that they are in a simple ratio by volume, provided that all gases are at same temperature and pressure, because temperature and pressure will definitely alter the rate of the reaction also and the amount of the product which is formed. So this condition is important. So when you talk about this Gay-Lussac's law of gaseous volume, so don't forget to write this, that is same temperature and pressure. Means when gases they combine or produce in a chemical reaction, they do so in a simple ratio by volume. So this volume word is important here. For example, this can be explained by taking example, that is under same conditions of temperature and pressure, 100 ml of, we are talking in terms of volume. So 100 ml of hydrogen, 100 ml of hydrogen combines with, combines with, this is the short form for it, combines with 50 ml of oxygen to give 100 ml of water. To give 100 ml of water vapor rather. Water vapor. Okay. So hydrogen, it is in gaseous phase, hydrogen gas plus oxygen again in a gaseous phase. It combined together to give water or rather water vapor. So 100 ml of this combines with 50 ml of oxygen to give 100 ml of water vapor. So this is two volume compared to this. This is 50. If you consider this as a one volume, so exactly this is the twice of this. So it would be two volume. So obviously this will be one volume and 100 ml is formed. That is again a two volume. So the ratio for this is, you can write here 2 is to 2 is to 1 is to 2. That's okay. So here the this law states that when gases combine or produce in a chemical reaction, they do so in a simple ratio. So this is the ratio for this by volume. So we found out this ratio by knowing the volume of this, isn't it? We are not considering this as a reaction in this manner. Remember, that is H2 plus O2 to give this twice H2O, or we are not balancing the reaction, or nothing we are doing. We came across this afterwards. But when you talk in terms of volume, this was the initial observation that 100 when 100 ml volume of this hydrogen combines with 50 ml of oxygen, it gives 100 ml of water vapor. So this is two volume, one volume, and that is a two volume. Okay. So as I told earlier also, this volume concept is important here. Now, the same thing can be explained by taking another example, like when 1 liter of nitrogen, nitrogen gas, obviously we are talking about the gaseous reaction, nitrogen gas, it combines with 3 liters of, combines with 3 liters of hydrogen, okay, hydrogen gas obviously, to produce, to produce 2 liters of ammonia, ammonia gas, okay. Now for this thing, same, you can write whatever I wrote in the wording, you can write this way also. Nitrogen gas combines with hydrogen gas, it forms ammonia. And what is the volume of this? That is 1 liter of this combines with 3 liters of hydrogen to give 2 liters of ammonia. So by looking at this volume, the ratio for this you can write as 1 is to 3 is to 2. So that is 1 is to 3 is to 2. Okay. Now this is about the Gay-Lussac's law. So this was a very preliminary or primary observation. It was put forth by Gay-Lussac. In states of matter chapter also we'll be studying this law. How does this reaction, they are affected, or rather they are dependent on the change in the temperature and pressure, because in this at this point of time we are considering this as we are seen in this law also, that is the temperature and pressure we are supposed to keep constant. Okay. So further, in further course of time, we'll be studying what is the effect of this change in temperature and pressure, and that is also given by this Gay-Lussac. This is the name of the scientist, and we'll be studying this in next chapter. Now, the next we'll go for this Avogadros law. Avogadros law. So this Avogadros law states that equal volume of all gases at same temperature and pressure, they contain equal number of molecules. Now in Gay-Lussac's law, I told you that it was related to volume. Now here comes the concept of molecules. This Gay-Lussac's law he explained in terms of volume, and Avogadro is the person who explained this in terms of number of molecules. Now according to Avogadro's law, if one volume contains n number of molecules or n molecules, then 2n, that is twice of this n molecules of hydrogen combines with n molecules of oxygen. Okay, to give twice n molecules of water. This okay, Lussac wrote or explained in terms of volume, and Avogadros he put forth the same concept of formation of water molecule in terms of molecules. Okay, so it means that when n twice n, that is H2, isn't it, combines with n molecules of oxygen, that is only one oxygen is there, to give this twice n molecules of water. It means that. So actually this reaction is not balanced here. Actually this should be like this, H2 plus O2. So H2O. So we have to balance this. We have to make this twice and then this twice. Okay. So we came across this situation after, but it was initially thought in the way of number of molecules. Okay. So 2n molecules combined with n, is n molecules, and it is giving 2n molecules of water. So you can, this is very evident from this reaction also. There are 2 molecules of hydrogen, 1 molecule of oxygen, and 2 molecules of this water as well. So this is the first person who explained this formation of molecules or the compounds in terms of number of molecules. Initially, it was thought by Gay-Lussac in terms of volume only. Now the next is Dalton's atomic theory. So as you all know that matter consists of tiny indivisible particles, which we call as atoms. All the atoms of given elements have identical properties, including mass. If you can, it means what does it mean? It means that if this is a sodium atom element, so all the atoms of this sodium will have identical mass. It means that atoms of different elements differ in mass, obviously. Third is compounds are formed when atoms of different elements combine in a fixed ratio. So when the compound is formed, the elements which are involved in the formation of those compounds, these elements or the atoms, they have the fixed ratio. Chemical reactions involve only the reorganization of atoms. So these are the four different points which were put forth by Dalton, that is called as the Dalton's atomic theory. Now, the next concept we'll be studying, that is atomic mass and the molecular mass. So before we proceed for this uh, atomic mass, this atomic mass is nothing but the mass of an atom. Remember, atomic mass means what? That is mass of an atom. I insert one more slide here. That is atomic mass. Means mass of atom. It is quite evident from the word also. So that is mass of atom. Mass of an atom. So it is actually very small. For example, the mass of one hydrogen atom. Mass of one hydrogen atom is equal to 1.6736 into 10 raised to power minus 24 grams. This much small value it has got. Mass of an atom, it is determined relative to the mass of carbon 12 atom at the standard. So whenever you determine the mass, so how do we determine, you can ask me, how do we determine that this is the value for this mass of hydrogen atom? It has to be compared with some standard value. So carbon 12, which is one of the isotope of this carbon element, carbon 12, which is abundantly available. So this is assigned as a standard. This is taken as a standard. Okay. So an atom of carbon 12 is assigned a mass of exactly 12 atomic mass. So carbon 12, it has the mass, it was assigned as a 12 atomic mass. AMU means atomic mass unit. Okay. And all other atoms of the other elements are given a relative atom mass to that of carbon. Means all the elements other than this carbon 12, they were compared with the mass of the atoms of carbon. Mass of the carbon is taken as 12, and in comparison with this carbon 12, the isotope of carbon, whose mass is taken as 12 atomic mass unit, all the other elements, masses of the atoms of those elements, those were compared in relation with this carbon 12. Means that. Okay. So as I told that carbon 12 is taken as a standard and all the masses are compared with this carbon 12. So 1 AMU is defined as the mass exactly. So what is this 1 AMU? 1 atomic mass unit. And write here atomic mass unit. AMU means what? Atomic mass unit. So this 1 AMU, this is exactly equal to 1/12 of the mass of, remember this is important, 1/12 of the mass of one carbon 12 atom. One carbon 12 atom. Okay. So you can write that 1 AMU equals to 1/12 into mass of 1 C12. Okay. So you can write here 1/12 into, that is 1.992648 into 10 raised to minus 23 grams. So the question arises from where this number comes. So this mass of carbon 12, it was determined by the technique mass spectroscopy. So once the mass of this carbon 12, one atom of carbon 12, it was determined by the technique like mass spectroscopy, and you got this value, and it was compared with this carbon 12, and 1 AMU, that will be equal to 1.66056 into 10 raised to, when you solve this, you will get this number, 10 raised to minus 24 grams. So this is nothing but 1 AMU, remember. So recently, AMU, it is it has been replaced by the unit instead of AMU. Now it has been replaced by the unit called U. Instead of AMU, the right here U. U means unified mass. What is this U? U is unified. Okay. So in this way, the atomic mass was determined. Now, in the next lecture, we'll talk about the molar mass or molecular mass and the remaining concept from this basic concept of chemistry. Thank you.